Hey everybody, how's it going? I'm Corey and welcome to my stream. Today is Sunday and we are going to be doing a nice chill Sunday stream. This is about an hour early for us. I'm still trying to work out a new schedule, but that's okay. We'll figure it out. So yeah, I'm Corey. Today we're going to do some Rust coding like we've been doing for the past while on stream. And we're going to be continuing on cache, our CDN caching proxy that is in desperate need of a README. That's probably going to be an off-stream activity for me, maybe later today, but I've got some other writing to get done, so definitely sometime this week. So cache is our CDN caching proxy. We can kind of see an example of it if we go to slow.coreyja.com, and this hasn't been refreshed in a while, so the slow one might take about 5 seconds this first time. 1, 2, 3, 4, 5, and then we should get a response. Awesome. And this is the timestamp of just now when it was refreshed, but if we keep refreshing, now this should be really quick. Now it's taking like no time at all, right? Boom, page loaded, and we're getting the old timestamp. And then I think in about a minute, our cache headers will expire and we will fetch a new one from the origin. So that's the basic flow of our cache. And let's pull up the repo locally and dive in. So we've been doing this really nice thing where every time when we wrap up, we write this little plan document of what we did on our last stream as a place to go over and start. So let's read there. What did we do last time? On our 5th stream, we tried to implement the LiteFS halt mechanism, and we used this litefs.go as our reference implementation. So we'll pull that up and just keep that open in a tab. We got to a spot in code where we expected it to work, but we haven't successfully gotten it working in Fly. And we haven't tried locally because it requires like multiple servers, and we just haven't tried locally. We might today on stream, but we'll see. For a long time on last stream, we were getting an error number 38 from the kernel, which we believe is an error no sys, or function not implemented, which is weird because LiteFS is made by fly.io, so we shouldn't get something that isn't implemented on their platform. I think, though, we fixed it by changing the command to setLockWait instead of just setLock. I think the wait one might be implemented in the kernel where the other one isn't. And so we got that to set, but now we're still getting the error return from database attempt to write a read-only database. So this is the bit that's interesting, and I'm wondering if we need to wait a little longer. Right now we just do the setLockWait and then we try to write to the database, but I'm wondering if we need to do some checks first to see. So I think that's what we're gonna start with. So to remind ourselves, just in case we didn't remember, what we're using LiteFS for. So let's pull up their docs, or their site. Their repo works. So LiteFS is a Fuse-based file system for replicating SQLite databases across a cluster of machines. It works as a pass-through file system that intercepts writes to SQLite databases in order to detect transaction boundaries and records changes on a per-transaction level into some files. So what that says is that really we can have multiple SQLites on multiple servers, and LiteFS is a way to synchronize them together. It replicates the database across a cluster of machines. And by default, LiteFS is really built for a read-heavy workflow where you have one write instance and everyone else is going to read that database. But it doesn't work quite as well when you have lots of writes, right? So you have every instance wants to do a write. And it does have some support, though, for this halting mode where you can issue a halt and then so then this causes writes to be halted on the primary node so that this replica can perform writes until unhalt is invoked. And so that's what we want to do. The problem that we were finding is that it didn't really work like we expected it to. Oh, so we didn't check this lag at all. I wonder if we want to try that. That could be interesting. Yeah, that would be kind of interesting to read the lag Because right now we're just, and actually we can take a look at our code. Because we have a LiteFS RS package, and we have halt, unhalt, and that's it. So we have two public functions, halt and unhalt. And they basically should be the halt and unhalt from the Go package. So halt, oh, I missed this for loop when I was reading this the first time. So apparently this loops and tries calling this exit on non this error. So what is this thing? Interrupted function call. Oh, okay. Many systems will report this if a signal occurred while the system call was in progress. No actual error occurred, it's just reported that way because the system isn't able to resume the system call automatically. This coding pattern simply retries the system call when this happens to ignore the interrupt. Oh, okay. Okay, so I could just restart it. Interesting. So that could be part of my issue, but I'm not positive if I feel like it is. But we'll keep that in our back pocket. They're looping if they get a interrupt error. But I don't think that's what's happening to me, to be honest. Okay, so we have our halt command. It gets the flock and type. And flock and type is we want to get the FCNTL lock type of right. So this is where things are interesting. Syscall right lock, is that just a right lock? Yeah, but like what are you? Not just that you exist. File locks, yeah. Okay, so it's one of those. Yep, got it. Right lock, yeah, okay, that's what I wanted. Yeah, so then I'm using this crate that does lock file, and actually that's something worth pulling up because I'm 99% sure I have a fork of that at the moment. Yeah, I do. Let's open this up too. Awesome. Okay, so this is the crate we're using to do the locks. So let's actually minimize it for a second. We want the lock file command or function. Lock file, here we go, okay. Okay, so it takes a file descriptor, a flock, and a lock type. The lock type is we get the thing from lock type or read. Okay, so we better be giving it a lock type. And we're giving it a lock type from get flock and type. Yep, so get flock and type is we're doing a right lock. Yep. And we do the halt byte, which is 72, which is the same lock byte they do. Start 72 length 1. Start 72 length 1. Type is the lock type into, and then we take the rest of the default options from flock. And we give it the lock type, which is right. Yep. So this is going to be passing down the right things, I believe. And then we match on the args on a flock. If you get a flock, wait. Yeah, matching flock. Okay, so if you got a from, you take that flock and set this lock type on it, which makes sense because you always want to set this lock type correctly. And then you say which type of command, and we're doing a set wait lock. with the args. And then, okay, cool. So if I get an okay true out, it thinks it's good. Okay, so let's see what we're getting when it returns, and it might mean we need to deploy with some logging, but we can do that. So let's check out our actual code. I'm just gonna move my mic out of my eye line. If you're hanging out on stream, definitely let me know if that messed up the sound too much, but I can't imagine it did. Okay, so here we should have a halt somewhere. Yeah, awesome. Okay, so if we have a database path, we're gonna try to halt. Ooh, is halting the database path what we want? Oh yeah, because we get a lock file from the database path, which is database path with the dash lock at the end. Okay, so I think that's gonna be right. Though I'm actually not positive if database path is gonna have like a trailing slash on it or something, which would be moderately interesting. Oh, I don't think that's actually an environment variable. I was thinking, well, it is an environment variable, but it's not a secret. Yeah, it's just right here. LiteFS cache db. So then this would put dash lock after it, which I think is what I want, right? It doesn't really give me an example here that's useful. Oh, this is LiteFS, it's getting started, which is fine, but it's not really what I wanted at the moment. I actually wanted this packages getting started. LiteFS go. Yeah, so, yep, that's the database path. Yeah, okay. So that's exactly what they're doing. So I think the file pathing is correct. So yeah, let's check what we're doing with the return value of this. And we don't check the true false here. Let halted was this. If halted, no, I want to do an info bang. Halted the database, else. Could not halt database, something like that, except there's some more formatting that's messed up here. Oh wow, lots of formatting that's messed up. There we go. Now I want this to be an error one because it's pretty errory. Tracing error, awesome. That's fine. I guess I can just remove it though. Okay. And then I guess I should do this, right? Let unhalted equals this, and then if unhalted database could not unhalt database, perfect. Remove that just because it wants me to. Okay. So now I think I want to deploy this. Deploy cache. Let's get this running. And while that's running, I'm gonna go let my cat out of my office here real quick. Okay, I'm back. Uh-oh. Failed to start, remote builder, failed building options, failed probing personal context, deadline exceeded. Okay, let's try again. Hopefully that doesn't mean Fly's having some issues. Ah, okay, yep, I needed a new WireGuard agent, it looks like, but we're running now. This does look like it's gonna probably be a clean build deploy, so it's gonna take a second. And hopefully we get some better info out of this to see what's going on. And actually, while that deploys, let's remind ourselves what we're doing with these tracing things. Tracing subscriber format in it. Perfect. Okay, so we're just taking the default format, so it should just be in logs. Okay, so let's pull the console up for that over here. Put that up here. I think GitHub's how I sign in. Yes, it is. Okay, okay. Slow server went to sleep. I think that's fine though. I think it wakes up when it needs to. One Mississippi. Yep, loaded. And then now is it gonna be awake? It's not a big deal if it's not. But like it responded a second ago. Okay, let's look at the activity here. Nope, monitoring. Monitoring. Cache hit for fast but stale. Requesting fast, cache hit for fast the next time. Love it. Awesome. Okay, cool. So we've got lots of nice little logs from here. And we're just waiting for the deploy. Nice. So I'm really curious if these logs are going to now have the right thing, right? Like I'm wondering if we get a true or false back. If we don't get a true or if we get a false back, that's what we need to investigate, right? Why are we getting, I think, permissioning errors are what would give us a false. E-access or E-gain. Oh, is that the... Oh, I'm on Apple right now, so that's where these both come from. Yeah, so, but it's E-access or E again? Oh, just E again. That's probably what that word is. Yeah, we will see if we get one of those once our deploy finishes. Taking a little longer, but that's okay. This is an uncached, undockered. There we go. Now we're pushing it places. Watch my deployment. There we go. We're waiting for 2 apps to start with the rolling strategy, which is nice. Gives us more of that blue-green deployment. It doesn't take the old ones out of service until the new ones are in service, and it goes one at a time. Nice, one machine done, waiting on the next one. Dropping stuff. Okay, there we go, we are deployed. Stream connected, connecting to cluster, EWR, awesome. Okay. 1, 2, 3, 4, 5. There we go. And now it's cached. Oh, wait. 1, 2, 3, 4. Oh, it wasn't cached. 1, 2, 3, 4, 5. Oh, why aren't they cached? I broke it. That's not what I was expecting to happen right there. Halted database, unhalted database. Cache hit for slow but stale. But stale. Huh. Well, that's interesting. Oh, now it's cached? No, it's not. It's still... Well, that's interesting. What did I do to break everything? Let's open up my HTTP client. Okay, so let's take a look at this thing. It thinks slow is in its cache, so entries are things that it actually has cached in memory, and pages are things that's in the SQLite database. And this is just getting absurd because it repeats things, and we're going to need to fix that, but that's not a right now issue. So let's hit slow on EWR, and it's going to take 1, 2, 3, 4, 5, 6. Perfect. Now if I do it again on EWR. Oh, okay. Perfect. So that's fine. I wonder if I was hitting the other region on accident. Oh, do I have DevTools open? No. Sometimes that was giving me an issue where I would have DevTools open in this browser and Chrome would always send the refresh cache stuff. That might be what's happening, so let's keep using paw where I get the correct behavior I'm looking for. Okay. So I think I just want to try what happens when I hit the other region for the first time. So this is hitting the replica where it's not going to have something cached yet. And I think it's going to blow up on me. 1, 2, 3, 4, 5, 6. There we go. Attempted to write a read-only database. Okay, but let's see what this thing said. Halted database. Yep. Can't create journal read-only replica. So the problem with this is that like I'm supposed to be halting. None of these seem like they're what I want. Can't find primary and ineligible become primary, and that's not what I'm getting at all. Andrew's using... Okay, yep, so I'm not using their proxy, so that's not what's going on with me. And it's not disconnection issues, it's just that okay, and I don't need pragma journal mode equals wall because apparently it supports both. Yeah. Okay, so let's take a look at their repo. Halt is like, okay, cool. Write forwarding, yep. If you use forwarding with regular write access, ensure the nodes are in the same region as the primary. For example, you can set your candidacy. Please note that SQLite write lock is held for one round trip plus the time it takes to execute the transaction on the replica. This means that performing a forwarded write when the primary is in Denver could mean that the write lock is held for a long time, which would limit your write throughput to only 4 writes per second. If you use forwarding with regular write access, such as for background job instance, ensure the nodes are in the same region as the primary. For example, you can set your candidacy to only your Denver nodes by setting this. Oh, least candidate. Oh, okay. I might need to mess with that. It might be that I told it that I was never a candidate for this. I need to figure out what candidate is. Yeah, it's not in the architecture. But I do kind of want it docked, so let's... Oh, okay. It's the only dock in there. Wow, okay. Least configuration specifies if this node can become primary. So I think I just want to try setting this to true. Script deploy cache. Let's try that. The reason I think I want to do that is because like I'm like kind of stealing the primary for a second with this, and I'm wondering, and actually because this doc implied, where was it? There was something to me that just implied. It was in the code. It was a comment in the code. In the actual it's this PR. This implies to me the candidacy to only your Denver node. So that kind of to me I think means that it respects candidate for even things that are promoted to write through halt. And if I was saying this could never be promoted to a writer through halting, I'm wondering if that's the problem. So if I just say anyone can become a primary, then in theory, this should work. And this is actually kind of fine with console. Like, I was making one a primary just because it was easier, but I don't really think it matters a ton which one is the primary for me, right? I was just setting the local region to me as the primary just to set something. But especially with we're supposed to be able to write from both now, it really shouldn't make a difference. So yeah, let's try this out and see what we see. And there's a few things that we'll want to do here too, right? Because this thing talked about if you have things far away, you could have the write lock held for something like 250 milliseconds, which would limit your write throughput. And that's totally reasonable. And so I think what I'm going to want to do is right now, the saving this is only for knowing a page exists in the cache. So it doesn't really matter to the user. So I think what I want to do is kick off a task to do this kind of in the background. And then return the response quickly so that the user doesn't have to wait for us to do our internal bookkeeping to receive their response back. And I think that'll help out a lot just with not wasting cycles. Like user cycles, right? Because that's what matters to the user, is just how fast the page comes through. Taking a little longer to do a build today, but oh, there we go. As soon as I talked about it, it's gonna go through. Okay, let's see. And actually, I want to watch the logs right now because I think they're gonna do different things with the primary. Node is already primary, skipping promotion. Okay, so that was fine for EWR. And LHR is gonna listening, no config, starting background process, acquiring. Oh, interesting. Primary lease acquired. Disconnected from acquiring existing lease from handoff. Oh, cool. So it flipped now. EWR looks like it's now my not primary. That's fun. Okay, but that looks like it's deployed. So let's give it a shot here. Okay, so list. What does EWR got? Nothing. What's LHR got? Nothing. Okay, let's do a fast request from LHR. 1 Mississippi. Boom. Okay, so this is the primary now, so that one we definitely expected to work. Requesting fast, halted, unhalted, but like nothing actually happened because it is the primary. And let's moment of truth it. Let's see what happens if I do EWR. 1 Mississippi. Attempt to write read-only database. So it's still the same thing. But it does the halt correctly. Well, maybe. Can't create journal read-only replica. So that like makes sense, except for the fact that I told you to halt. So I feel like I'm messing up the halt somewhere, but it's on the right file because it's -lock, database path -lock, right? Yep. And it thinks it did it right. Like it thinks it had permission. Okay, so DB files are DB lock file, which is just good to know. Yeah, interesting. Inserting row, committing transaction. So I could try to do it in a transaction. Replicas will forward writes in wall mode skipping. Yeah, this isn't really helpful for me. There's all kinds of stuff here, but okay, let's go back to the Go implementation. Go.mod, that just references LiteFS.go. Okay, so there's halt, there's unhalt, there's with halt, and then there's lag. Error not replicated. Initial replication from primary not finished. Okay, got it. So there's just a file that gets written that tells us the lag. Okay, so let's add that. Public function lag. I think I just need database path. Yeah. Database path. You're going to return a result of just an integer. Time.duration. Yeah, I guess that makes sense. Okay, so let lag. Let's lag file. Let's do that first. Equals a format shebang of, except it's not quite that. Apparently, it's like, I don't like it for that. Plus, oh, dot lag. That's the dot lag file. That makes more sense. Oh, I don't know what this is gonna be a result of. Let lag equals read file. Standard. Oh, actually, I probably want this to be Tokyo FS read to string. Yeah, that. Yeah, that's why I have to make this an async function. Now we can await it. Oh, I don't have Tokyo here in light of our. Oh, okay. This is I'm doing. Okay, cool. Well, that's fine then. No await. Oh, this is standard, not FS. Standard FS read to string. And it returns an IO result. Standard IO result of a duration. Perfect. Yep. Yep. Oh, except it's not from millis, it's from time. Yeah. So these are in seconds. They're sent at 1 second intervals. Yep. From seconds? Yeah. From seconds lag. And then it's okay on lag. Nice. Okay, awesome. So now we can report the lag. Hopefully. I'm actually kind of confused by this thing. Oh, because it's LiteFS, we can just do whatever the hell we feel like. Is that the answer here? Because that's pretty crazy. But that's working. So let's move up to the repo where we want to use this, and we're gonna use the lag, and we're gonna do it right before we do all of this stuff. Let lag equals. Oh no, we do want to do it in here. Let lag equals. Yep. There's no awaiting. Oh wait, did I make it async even though it doesn't do asyncy things? I did. No more awaiting it. We just into diagnostics it. Info bang lag. I also can do lag at the beginning to send it as a tag. Oh, nice. Primary, I don't know. Got lag from primary. I don't know. Not sure that's my favorite log. And I don't think I really need this here. Cool. Let's try this. Let's see a few things here. One, are we just doing things correctly? Like, can we get the lag from this? And two, what is the lag? Like, is it very laggy? Is there a fact that, like, do I need to do this halt, then wait a few seconds before it, like, triggers? That would be interesting. And I could totally just do, like, a sleep 1 or 2 seconds at the moment. It'd be awful for throughput, but, like, hey. It doesn't seem like it's just getting the halt at all. And this thing is doing some file permission stuff that I want to check if I'm doing. Lock file. Yeah. Okay, so like permissions or something. Okay, so open options rust 666. How do I set this permission? Yeah. Mode. Yeah, okay. Let's get rid of all of these, I think, and just do .mode. Yeah, except I want to come on. Yeah, import it. Cool. If no mode is set, the default of O, of course. Dang it. Well, we're gonna try. I don't think there's any custom flags that we're setting, do we? I don't think this is exciting. Okay, well, which one is this? Open for reading and writing. Yeah. So I guess actually maybe I'll keep all of these. Read, write, create, and then also do a dot mode. Do all of them? Oh. Okay, I think this deploys just for checking the lag. So that's okay though. Let's check this. Primary lease acquired. It's interesting to me that like we hand off who's primary a lot in this thing. So I think EWR is back to being primary. Except let's just see. Oh no, it flipped. LHR is primary again. Disconnected from primary with error, invalid response. So it's interesting that that's happening. I think it's like fine, but it's interesting for sure. Okay. But we want to check the logs when we make some requests. So let's do a one on what I think is our primary. On Mississippi. Ooh, not a file or directory. Awesome. Okay, so lag's just not working, which means I think something else is up. It doesn't seem like things are working right. I'm assuming that's just on that lag file. Oh, that's funny. I actually was just talking at RustConf with someone about how it's slightly annoying that all the normal FS errors don't have the file name in the middle. Just because it's annoying. And I think that's what's happening here, is this lag isn't working right. Database path /.lag. Yeah, okay, so that doesn't work. At least for me at the moment. Lag? No. Okay. So their docs leave something to be desired just a little bit. Lag node. Not really sure where I'd be looking for this. LiteFS lag file. Similar to would be useful for applications to be able to track the current latency. To be expose latency for Prometheus metrics, so it's just a matter of wiring it up to Fuse. Yeah, okay. I ended up changing the .lag file to be milliseconds different, so that might have gotten flipped again. Trying to see if from here I can tell where this freaking .lag file lives. Lag file name .lag. Okay, got it. Where do you live though? So is this the Fuse thingy? Lookup returns a node for a file in the root directory. So like kinda. In the root directory. Okay, let's look at the tests. There's got to be some tests for this. File system test. Okay, so we get a temp directory. And we join the path with DB, and that's our database. Path. Okay, so .lag lives next to the database. Yes. Yes. So database path here. No. Equals a type of path, but it's not a path buff. Thank you. Perfect. Let database path parent unwrap join .lag. This is lag file. Okay, because now we're reading the lag file that sits next to the database, not in the database. Not like, yeah, because that didn't really make sense. Script deploy. So the hope here is now that we can, well, now that hopefully we can read the lag file, and that will help us learn something. But I'm also going to check about this lock file now. Now that I like kind of have a place to be looking, it's in this file system. Let's open this file. View file. Yes, I know it's not a recent one but that's okay. Let's use your latest tag because I assume that's what I'm running. So there's a lag file here, right? Yep. It's the only time we see the lag file name in here, though. That's okay. Yeah, this is maybe what I was looking for. Primary file name. Dot primary. Interesting. Oh yeah, in here. There we go. Yeah. Attempt to lock the database. db-lock, yeah, okay, so that is the the name of it. It's just dash lock. Okay. Yeah, so the dash lock looks right to me. Oh, what kind of thing are you? Oh, you're an option. Oh, okay. That I could have done something with that. Okay, pushing our things up. Yay, first one exited. Oh, cool. So this time LHR said that it, okay, so EWR is our primary right now. Then LHR comes up and probably steals it, which is fine. It's just super interesting. Yeah, LHR is now primary. Okay, cool. Okay, fast in LHR. 1 Mississippi. 502 bad gateway. Okay. Oh, we called unwrap at an error, parse invalid digest. Oh, okay. Invalid digit. Cool. Didn't even think about that one. Info bang. Lag, comma. String lag. Stringy lag. Oh, we're in LiteFS. I don't have tracing in here. Should probably just add tracing. Cargo add tracing. Cool. But like that's all the thing in Go was doing, right? Also, the thing in Go was a little wrong, anyways. Though, this lag is not quite. Oh, it gets the directory of the database path. Yeah, so that actually is correct. Missed that. Oh, wait. Parse in 1032. What's this? Ooh. Ooh. What are you? How do you work? Go. Parse int. What do you take in? Returns the widest. Returns a oh, okay. So that's base 1032. That's not exciting. But it does do trimming spaces, right? Is that what it does? That was interesting. This is the PR, but I just wanted this there. There we go. Yeah, so it does a trim space. Is that what I need? Because if so, that's easy. Let's try that. Deploy. Would be nice to move some of these things so I don't need to deploy every time. Oh, it would also be nice to have a better error return there, but this is a library, so we will need to clean all that up and make some better error types. But we might do that on a separate stream. We'll get this working for us, and then we'll get LiteFS published on a separate stream. That kind of sounds like a good plan to me. Could probably like try to build these locally, so then I could just keep my cache a little better and push them up. Except actually everything is cached. I just think I'm not using Cargo Chef at the moment for actual caching. Yeah, this is a cacherless thing, which is fine, but not as exciting as it could be. Yeah, and then the connection got closed, yeah, because I just aborted the whole thing. While we're waiting to deploy here, we are kind of, well, hopefully we'll see how many more times it takes to get this halting working. We're definitely getting close on this CDN project, so if you have some other fun projects that you think I should work on or that you'd like to see on stream, definitely reach out and let me know. Leave a comment on YouTube, give me a Twitch chat, find me on Discord, wherever. But I'd love to hear what people are interested in and would like to watch. Okay, come on. Maybe if I talk about it, it'll do what it's been doing and finally get it up here. Nope, we're still waiting. I was hoping that this time it was gonna be the nice trick of just talking about it just enough. Got it to kick off. There we go. Okay. Pushed. There we go. We should see some logs. EWR is booting. Acquiring existing lease from handoff. Primary lease acquired. Then it's gonna flip everything around. No WAL file exists, skipping sync with LTX, sure. Connecting as a replica to this, stream connected. Node is a candidate, automatically promoting, existing primary, preserving lease for handoff. Can't connect to self, connect to primary with errors, retrying. Okay, interesting. Primary acquired advertising as, okay, super interesting. Okay, but we're back up and ready to go. One Mississippi. This one should not error this time. I think the trim was probably the thing that we needed. Oh. Okay, that took a little while. Okay, string lag of nothing. Got lag from primary of nothing. That makes sense. So let's try the other region. One Mississippi, and then attempted to read only database. Got lag of 218 seconds? Is this seconds or is this milliseconds? I thought this was supposed to be seconds, but that hopefully is milliseconds, because that is a lot. Let's go back to this PR. I ended up changing the lag file to be the millisecond difference. On the primary, it will always be 0 if we haven't got a timestamp from the primary. It'll be the max. I didn't want to use -1 since that's a valid amount if there's some clock skew. Okay, so I think these are milliseconds now, not seconds. So what if I just had a sleep in here? So two things. One, I think this is from millis. And two, what if my halt just does a sleep for 1 second? Oh, duration from seconds 1. Oh, let return. So we do this thing, we sleep for a second, and then we return. Is this the best? Absolutely not, but I want to see if that helps. We're also changing the lag number to be milliseconds because I'm 99% sure that's what it is. Okay, we really need to make these deploys faster, don't we? Or we just need to stop doing deploy-driven development. I guess that would work too. I'm like a little bit concerned that the path is just not the right path, but it seems like it is the right path. Yeah, it's just database path dash lock. And it is that, right? It's not... It's not like joined as a new... No, that doesn't make sense. With halt. Cool. Oh, there it is. Yeah, it's just a plus. Yeah, yeah, that's all right. Okay, that's what I thought, but just checking. Database path lock. All these options. Yeah. Got lag from primary lag equals 118 seconds. Got lag from primary 0. Yep. Because if you are the primary, your lag is 0. Cool. First one down. Boop. Next one will cycle in just a second. I'm not really going to try to messing with it while it deploys. There's no reason for me to try that. Like, once we get this working, that can definitely be a thing we stress test. But for the moment, we don't need to mess with that. Awesome. Okay. Primary. Fast. Go. Works great. Didn't expect anything else. And it caches. 1, 2, 3. Yeah, I still can't write to a read-only database. 258 milliseconds. I could try halting for 258 seconds, but I don't think that's going to be the issue. Halted database. And then it blows up. Yeah. Oh, and now it doesn't even try this code path, right? I would need to do slow with the replica. 1 Mississippi, 2, 3, 4, 5, 6, 7. There we go. Yeah. Yeah, this has got to be milliseconds. There's... Well, actually, does it? 3, that would be 10 minutes. Oh, yeah, I didn't deploy 10 minutes ago. It can't be that. Um, 1, 2, blow up. Ooh. This one got it a lot. Wonder why it got it so many times there. No. Cache it, yeah. Interesting. Can't create a journal on a read-only replica. I get that, but I'm supposed to be doing this silly halt dance where you're supposed to then decide that you can do it. fcntell flock. And we do a set lock weight. It's 38, yeah, and I think that's what it's defined as in this file. See something called 38. Oh, okay, well. Wait. Is there a thing that converts this? From this. This is interesting. Lock type. 789. Interesting. 36. Oh. That's moderately interesting, isn't it? Yeah, it's set at 7. Wait, what? Oh, this is Apple, though. Was that part of my problem? I feel like I'm confused by lock type versus lock command. Those are lock constants. That doesn't really help me. So this does a syscall of this thing. The type is a write lock. Yeah, okay. That makes sense. So the type is a write lock. Okay, so that's this FR write lock. FR write lock. Yep. Okay. Got it. So then this is a F. Wait, what's this? FOFD. Open file descriptor locks. Got it. This macro is used as a command argument to this to specify it should set or clear a lock. It's just like the this command, but causes the process to wait until it's been completed. Yeah. Open file descriptor locks are useful in the same sorts of situation as process associated locks. They can be used to synchronize file access between threads within the same process by having each thread perform its own open on the file and attain its own open file descriptor. Because open file description locks are automatically freed upon closing the last file descriptor that refers to the open file. This locking mechanism avoids the possibility that locks are inadvertently released due to a library routine opening and closing a file without the application being aware. As with process associated locks, open file descriptor locks are advisory. Yep. Oh, wait. I'm not doing the open file descriptor variants of these. Oh, okay. Okay. This. So I think it's just a separate thing that I need to pass into. So where we do the int conversions of all of these things. Is there multiple? Is there another that I can do? Yeah. Oh, but not for those ones, for these ones. Open file descriptor, set wait lock. Open file descriptor, set wait lock. Yeah, so it is 38. Where are you? There we go. F. Yeah, lock. Wait. So that might be the problem. Shouldn't this be in libc though? Yeah, it is. It's right here, libc. Oh. What do I, like, is there a feature flag for this or something? Yeah, like, why can't I just grab this from libc? It's right here. Might not exist here. It seems like it does. Yeah, it is. Okay. Well, that's why I want the libc thing, because then on OS X it's a different thing. Okay, that's a fun one. But like I see it here. Like I see it. But is it just because I'm on a different platform? Yeah, I'm on unknown Linux. So can I try it for this? Arch 64 ARM. I'm actually not sure what the right one of these is. Apple. That's the only. Oh, there we go. Oh, that's x86. What if I want Darwin? Yeah. x86 Apple Darwin. Okay. ARM libc Darwin Rust. I don't know where I am. Okay. Arch 64. That's the one I want. Okay. platforms. Huh. That's interesting. Is there not a here's what I should do. Docker. You running? Now you are. There we go. Docker. Docker build file cache. Docker file. What? Oh. Build this directory, that file. Okay. I want to see, wait, what did I do? Did I do this with that thing in there? Is that what's in here right now? The thing that doesn't look like it's gonna compile? Oh, I also don't get changes here automatically. Or my deployed version doesn't at a minimum. Actually, what the hell is this doing? Yeah, it just uses this commit hash. It isn't useful. Okay. So if I want to do this, I guess I just write 38 in here for the moment. Yeah, let's just do that, I think. Oh, this is LiteFS. Oh, no, it's in the CDN, right? No, this is this thing. There we go. I was getting confused. Okay. Add a command for open file descriptor locking. Yeah. Okay. Let's push that. Yep. Set the upstream. Okay. Is that what I needed though? Fork? Yeah, fork is what I needed. Okay. So now I have a new thing with a new commit hash. Copy it. Go to here. Use the new commit hash. Or go, oh, this one wants to be. Oh, I see. Am I in the same one in both? That's funny. CDN. Build. Cool. Grab that new commit. Okay. Cool. Waiting for a remote builder. Awesome. Okay. So this one might actually work. I was doing the wrong thing for a long time. This isn't going to work for two reasons. One, I didn't set the command right. Oh, I might need to change more over here. I forgot how much was in here. Okay. Lock file. Okay, well, let's just do open. Yeah, okay, so this is like gonna be pretty messed up. But that's okay. I think unlock file is also going to be pretty broken. Because I'm also going to need... Well, there's a few things that are going to be silly about this. I don't know, let's leave unlocking for the moment. That's fine. We'll try it out. Yeah, so lock file is now gonna do open file descriptor set lock wait. Which means I probably should just be using FCNTL directly. Oh, because I aborted it. Yep. Use the new command. Push my fork. Copy. Let's tell it to run this version. Cool, builds locally. Let's give it a deploy. I feel pretty good about this though. I think this was the big thing. I wasn't doing the file descriptor lock, I was doing a file lock, and that's just not the right thing. So I think that was basically the big one. So we're using this FCNTL crate, which I think we're gonna redo a bit of, or at least expand on a bit. Didn't really do all the things I needed it to do. That is a little annoying though, because it means that things won't run on OS X. Sorry, I was thinking in my head and not talking. I'm wondering if part of the problem with this is that the open file descriptor stuff is different on Darwin, or it might not even work on Darwin. So I might have to like do some stuff to make my code be runnable without Darwin, without this whole thing. So I think it's basically like we will only do LiteFS in deployment in production on Unix platforms. So as long as we skip the halting and stuff on those platforms, we should be good. But I'm definitely gonna need to code that up a little bit. But that's okay. If this works, this would be awesome. This would get us off the ground and we keep running at some other stuff. Okay, come on, let's build faster. Build faster. Oh, hey, how's it going, viewers? We got a few more, it sounds like. Thanks for stopping by. We're working on our caching proxy CDN at the moment, and I'm Corey. We're working on getting it deployed done. So part of this CDN is that we have multiple nodes throughout the world. I have one deployed in Paris and one in New Jersey at the moment, just to test it out. And so what we're working on is getting a SQLite DB replicated across those regions, which has been working for a while now using LiteFS. And what we're really trying to do is allow writes from any region using LiteFS's halt mode. So you set the lock on some specific file descriptor, and then that tells LiteFS that you want to forward writes to the primary node from your read-only node. And I think this might be the deploy that gets that working. Before we were locking we were not doing an open file descriptor lock, and we were just doing a file lock. And I think that was basically our big issue. So once this deploy goes through, we'll wait for both of these machines to be up, and we will do some HTTP requests in our little tester and see how it's going. This should go green really quickly. There's not this app boots fast. There we go. Okay, let's check out monitoring. We've got some good logs. Nice. Let's go to paw. So Paris is actually going to be our primary at the moment. This should work in 1 second. There we go. Oh, there might be a 1 second delay, so that's probably 2 seconds, but that's okay. And then now we get only 100 and something milliseconds. Here's a moment of truth though. Switch to our replica. 1, 2. Attempt to write to read-only database. Oh man, really thought that one was gonna do it. So we had 360 milliseconds of lag, sure. We tried to halt the database, and then we got read-only replica errors. Halted database, yes, we got a true back. So the syscall worked. Dang it, I really thought that one might do it. Okay, so this was 6. Is that the one I wanted? 6B? Oh, this is the wrong thing. Okay, let's open a new one of these. New session? No. Oh, new session was what I wanted. It was perfect. We want to go do this thing. Awesome. Yeah, 6B. That's the one we want. So my lock type here should be a write lock. The command should be open file descriptor set lock wait, which is this thing, which is a 38 when we get the number for it. Yep. Also, the numbers are different on OS X versus where we deploy, but 38 should be the right number for Unix where we deploy. And we didn't get any errors, which is also a little weird actually now that I say that out loud. I guess it's not that weird, but check file locking simple. Yeah, okay. Okay. Huh. I really thought that one was gonna do it, if we're being honest. Yep, because we've got our lock file. It doesn't actually lock the file anymore. Because it does an open file descriptor set lock wait. When it gets that, it calls the libc thing with our file descriptor, the command, and our flock. And if it gets a 0 back, it's good. And if it doesn't, it does some error handling. Oh, and I told it that set lock wait was implemented, which I really don't think it just was. I don't think there was anything to even do. Okay. Yeah, that's file locked, which is fine. I'm not even really looking at you there. Yeah. This is just basically just a pass through for this with the right things. Yeah, and it's just the thing inside of this. Yep, and this is like the libc flock. Yep. Open file descriptor set lock wait. Yeah, this is the thing that's 38, right? Doesn't actually tell me what the number is here. Yeah, that's the Apple one. Yeah, okay. So it's 38 on these platforms, and it's like not even in these docs on other platforms. Super interesting. So I wonder where you're used on this platform. So this is almost a Linux only thing for the file descriptors. Oh man, I feel like we're so close, but we're not figuring it out. And we are using the right version of this because like that's just like I told it to use my fork 6B. Yep, so it's definitely grabbing the right version of it. Yeah, and our lock type should be right. Yeah, can I like see where you're using this in code? No. RS streams repository. Just that you're re-exporting it? Yeah, it's just re-exported. Wow. That's crazy. I've never seen that before. This like it's being processed. Yeah, I think it's just being re-exported. I'm pretty sure it's not actually here. Got it. Mm-hmm. Yeah. So if you get a... Oh, great. Okay. So those ones are just not implemented on these platform on any platform. Okay. Let's find a new one. These ones are almost always just re-exports, I'm guessing. Yeah, this is just in the Nix thing again, which is what I just got it from. File descriptors. Interesting. I'm not sure any of these are actually what I'm looking for at all. Open file description locks Rust. File lock. What are you? Repository. What are you doing? It is a build.rs file. Uh-oh. I'm not sure I like that. Yep, that's not enough for me. That's just file locking. That's the one I just looked at. FS lock. This doesn't do anything different either, it doesn't look like. I bet you don't know about this thing. Yep. File guard. Yeah, they're also not going to know about this thing because I need it. Like, it's fine to be Unix only. Like, it kind of needs to be. Okay, so it seems like we're going to be the first to publish this crate once we get there. It's just going to take me a little bit to get there, apparently. Okay. Rust block. Cross-platform. No libc, pure Rust, cross-platform file locks. Okay, but like, the problem is, I probably just want libc. And I don't want cross-platform, which is kind of funny. For data streams. Okay, so this doesn't seem like it's very helpful at all. None of these did. Like, it just needs to work on Unix. Like, it's pretty fine if it's just Unix. I wonder what the syscall bang is. That's a fun one. libc syscall. Oh, macro rules. Nice. Nice, just as the error handling. So I kind of just want to move the libc stuff into this instead of having it in the separate. No, but I do. Well, we'll extract it later, right? We'll have light up. Yeah, let's extract it later once I get anything working. Oh, let's try, but I'm really not that confident that this is gonna be the thing that gets it working, but because there's not that much going on in this. So let's pull some stuff out. Let's do these side by side for the moment, I think. Don't need that, don't need that. Okay, so here. Oh, undo. Let file descriptor equals that. That's gonna need a this. That's fine though. Okay. Okay. Let mutable. Let mutable flock. Get flock and type. Is that in? Oh no, that's here. Awesome. Okay. Get flock and type. I really just want get flock. I don't think I need to type anymore. Get flock. Okay, and then eventually I'm gonna do this. Oops, did it again. Z open this. Okay. That's just an import, right? Command.into, this is a number. So this is let block command equals 38. This is this block command. Into try into dot unwrap maybe, just in case. I don't really know. Okay, if return value equals 0, true. Yep. What? Oh. There we go. Okay. Because this is the type. Yes, we just need the block. Oh, the type was okay. Yeah, that's just because their API was silly. Okay. This is not doing anything different though. It's just putting the code directly in here. And then the thing for getting unlock working is like the opposite stuff. So it calls the same thing with a different one of those, which is weird. So unhalt is gonna be a lot of the same stuff here. Block type is right. Yep. I guess I'm gonna make it some mutable flock, and then it's gonna be block dot type. Yep. Oh, wait. Unlock file. With L type. Oh, L type is different than lock type. Like if this code's formatted, it's very hard for me to find things. Yeah, that one definitely doesn't feel like a thing to, because like it is a C short, so it's fine to put in a C short. What block type? Now we're gonna copy this whole block and put it in here as unhalt. Let fd equals log file fd. Oh, I didn't really want a doc comment there. I just wanted a comment. Okay. And then that build. It does. Okay, awesome. Let's minimize you, make you bigger. Because what I want to do next is say that you don't depend on this at all. That's gonna break some stuff. Okay. A tuple of I32 and I32 option with I32. Just do tuple. Yeah, use the libc block. I think I just want to get rid of this method. Oh. Okay, lock type is right, but I always want to write lock, so what's that? Yeah, right. This. Oh, it implemented the default. Oh, I forgot. Default's just like a method on this. That's fine. It's just silly. This one, default. Default block. Default block. Block. This just doesn't exist at all. Yep. Okay. With lock type, don't need to set that. Okay. Remove the FCN something something FCN TL. Yep. We will bring it back later once locking is working. The idea is we'll extract to a nice thing once that we actually have something working. I don't really think this is going to do anything different. This was just copying and pasting the code from the library into this here, but we are removing a level of abstraction that just wasn't helping us. So maybe this will work better. Just taking a look at my laptop. Nothing exciting though, but we've got like 90 seconds to kill while this deploys, so. Let's do this while we're waiting. If you enjoy my streams and want to help keep them going, I've got GitHub sponsor set up. If you go to my GitHub profile, github.com/CoreyJ, sorry about that. You can check on the sponsorships and head on over to GitHub sponsors, where you could contribute and give me a few dollars to keep these streams going. Backwards Spy is and was my first contributor, and so many thanks to you, Backwards Spy. But if you've been watching along, that would be a great way to help me keep doing these videos. And if that's not feasible for you, that's totally okay. But if it is, I'd love some support. Okay, we've got maybe 30 more seconds before this deploys. I really thought this last one, honestly, was gonna be the one. So this 38's just like a magic number. And so we're gonna try this out, because let's actually look at we're doing things a little more directly now, so I think we could look at the Go code and compare. Yep, it does the FC until flock, which actually, let's look up this in Go. Forms the system call for the underscore. Oh yeah, but that's just, they're obviously doing that, so the docs are just wrong. Yep. Awesome. Oh. Okay, so the unlocking is wrong for sure. Because unlock. No. We're using this thing correctly. Cool. I didn't realize that this was set to I did that right. Yeah, we set it to right lock here because that's what we want when we create it. Yep, and we set it to unlock when we're doing this. Okay, never mind. Yeah, we're waiting for the deploy. Oh, uh-oh. Mismatched types. Okay. Line 44 and line 99. Expected found. Okay, so this one needs a try into dot unwrap. And then 99 probably needs a thing. Yeah. Try that again. So that's the problem with all the different machines. They have different like sizes of these integers, so like it's kind of silly that I need a try into when it's an i16, but it just doesn't know it's an i16 on all the platforms, so that messages aren't that helpful. I really probably should. If we're still if we don't get this the next 30-ish minutes, when I'm probably planning on wrapping up, next time we might, I'm not gonna say probably, we might get a Linux VM so we don't have to, that we can do everything in, so that we don't have to deal with the deploys and waiting for everything with the deploy. Yeah, so I hope we do get to publish 2 crates out of this, though. One will have cache, which is probably not going to be published as a crate, just because it's an application and it just doesn't need to be. We'll probably put up some dists on GitHub to download it if you want to. But then hopefully we'll have a LiteFS crate that comes out of this, and probably another flock crate, something with these flock file lockings. Because I think it would be nice to get that lower level stuff published as well. Doesn't seem like there's great support for it in Rust right now, and it would be nice to not have to interface with libc directly. It's not too bad interfacing with libc directly, except I haven't figured out how to freaking get it working. And that one's a little unfortunate. It does feel like when I set this, I should get some logs from LiteFS being like, hey, something, something, something. Oh my gosh, okay. Oh. Into diagnostic, but its trait bounds were not satisfied. Do I not have into diagnostic in scope? No. Oh, probably because it doesn't implement error or anything. Yeah. Yeah, that might be it. What if I just... Error number is the second thing. Okay. Pub struct block error number and return value as an I32. So this is just then a block error. Error of a block error where you got error number and error number, return value, and that's it. Yeah, that. Yep, okay. Block error. And then I want to do something like CD to LiteFS cargo add blah, blah, blah. So this isn't what I want. I want the thing that plays well with it. It's this error. I think it's this error, right? Yeah. And I want to add something like this. Import error from this error. Import diagnostic. Oh, we don't have diagnostic here. That makes sense. That's fine. But display is not implemented. Oh yeah, for error number. Okay. Rust display, or actually I can just implement display. Impl display for block error. Implement the basic number, so f dot write format Uh, Rust impl display. I just want an example. Let's do this. This is better. Right bang. Block error. Block error. Return value equals return value. Oh, this might not work here. And then errno equals that. So self dot return value self dot error number unwrappable. Map it with a string to string. Doesn't implement. Yeah. Unwrap for default. Dang, I thought I could do that. So I can just do this x dot to string. Yeah, that'll work. Okay, there we go. Now this implements this. Cargo build. Least builds on my platform. Let's get it deployed. I changed some. Oh no, it's the same stuff. We're just building the same thing every time. I didn't have my water bottle with me last stream, and it's much better to have a nice thing of water to drink while I stream. Gives me something to take a break with, and my mouth doesn't get as dry. Imagine that. Okay. So what did we do since the last deploy? Oh, we just haven't actually got a deploy out in a while. We've had build errors. I guess I should have just seen if cache could deploy locally without errors before I did all this, but let's see. What do you think here? No error messages, so I think that means we did it better. We just had to get it to implement error. Do. Getting our LiteFS thing compiled just now. After that, our cache implementation should refresh. Or not refresh, but compile. Okay, there we go. This shouldn't take too long, I don't think. Woohoo! Okay. Yep, one box deployed. Next one coming up. Okay, I think this is the first time we have it deployed without the extra crate in the middle, which will be nice. Awesome. Okay. Logs. Yeah, give me a new page of logs. There we go. Okay. Primary is existing primary found. Stream connect. Yep. Okay. Still Paris. Is this Paris? Where did I move it? Heathrow. So this is London. It's not in Paris. We were in Paris at one point, but now we're in London. Okay, so London. Works great. Now it's cached. Love it. New Jersey. Yeah. Okay. Only a little bit of lag. That's nice. Halted database. Can't create journal. Read only replica. Man. And we get the halt comes back. Oh, I just kind of threw that in the middle there. Not my favorite, but that's okay. Yeah, this is 38 equals that. Let's just do that. It never returns okay, false. Just don't need the true false there, it's not helpful. Okay, but that's gonna break this, which is fine-ish. It's just that we never could not halt the database. It's just always this, which just makes sense why I've never seen those failures. Definitely don't need that. Definitely don't need that. But this doesn't help me at all. There is the go is locked, right? There's this, wait, I thought it implemented a is locked. Oh, that must just be in the other, the F's, the Rust create. Okay. And we're not getting this error. We'd see it if we were getting this error. Things initialized to 0 in Go, so that makes sense. I want everything else initialized to 0. And the Rust spread operator is different. Your syntax is a bit off, but like it's also not exactly the same, right? Destructuring works great. Where's this? Ranges. Okay, well, not those for ranges. Bindings. Rust default struct with some fields. I don't think I have this wrong. I just want to make sure that is the better way to do this. Doesn't work because the struct doesn't implement default because of the one. Oh, okay, yeah. Then you don't cover is just to put all the optional fields in its own type. Well, okay. Yeah, but this is what I want. The dot default. Yeah, okay, so I don't think that's wrong. Though it would be pretty funny if flipping it did something exciting. Is that even valid syntax? You can't use a comma after the base struct. The base struct must always be the last field. Yeah, that makes sense. I do not know what the F is going on. It seems like everything should be working. It's just not. I think I even have that sleep still in, don't I? Did I get? No, I'm not sleeping anymore. I got rid of that. Okay. Because that was in lock file. That was in lock here. That was in halt. Oh, okay. Yeah, I just inlined that to 38. Let's inline it here as well. The only thing difference is the flock. Where this one we just get the normal one, this one we get the normal one and change its L type. Yep, that makes a lot of sense. And this one's an unlock because it's this, and this one's a right lock because, oh, and that's the default that I'm using. I don't like that. But it's a right lock. And we're opening the lock file with the right things here. Database path dash lock. Yeah, like this is exactly what the Go code's doing. Just on the file descriptor, which sure, whatever. This one doesn't even actually. Oh, but with halt calls halt with the database path plus lock. Yep. RW, yeah. That's what I'm opening mine with. Well, it's yeah. The lag function works great. I can read the lag nicely. Oh, wait a second. Is it because things are going out of scope? When I close the file descriptor, because this returns a file. Oh, and when I close that, that might be going out of scope. Okay. What if lock file became public? And then this, what if halt took a lock file is a file? Yep, and then this also took a lock file of a file. Yep. They haven't written the with locky thing yet, but that's okay. Let lock file equals LiteFS. No, lock file. I don't think it returns an option. Yep. Okay. Lag does that. Yep. This though takes lock file. This is sum of a lock file. Else none. Yep. Nope, I missed an else. Perfect. Okay, and then this is if let some lock file. If the lock file still exists, use it. Okay, so I think what's happening is the file descriptor goes out of scope. Halt and unhalt probably can just take a reference to this file, I imagine. Let's do it. Okay. That might do something different. I think what was happening is I was acquiring the lock, then dropping the file descriptor, which immediately closed the lock. I'm not actually positive about that. The more I think about it, the more I'm unsure, but let's give it a shot. I was definitely closing that file descriptor right away. File descriptor lock Unix close file. Like, I don't know. Yeah. Yep. There we go. When you call close on a file descriptor, it no longer refers to a file and may be reused. Any file locks that we call with fcntl held on the file associated or owned by the process are removed. There we go. There we go. So as soon as I locked the file, I closed the file descriptor and gave up my lock. Okay. I think this might do it. Fingers crossed, team. But this might be the thing that gets us replicated SQLite transactions on our replica. I think this might do it. I think that'll do it, because when I closed the file descriptor, I gave up the lock. It makes so much sense. Man, this is the longest compile, because I'm really excited for this one. Okay, come on, Rust. Give me some faster compiles so that we can see if this was a success. That's fine, I don't need that import. That's a fine warning. Just actually compile and we'll be good to go. Oh, we got 5 people. Thanks for stopping by, everyone. We are deploying our CDN right now. Hopefully, with the last file locking bits in place to get LiteFS halting work. So the idea here is we have a SQLite database that's replicated in multiple regions by LiteFS, and right now only the primary region can do writes to the database, which makes sense for speed and stability and those kind of things. But we have a pretty low write volume for this, or we're playing around, so we think we're gonna have a low write volume for this database that just records what we have cached in our CDN. And so we're trying to make it so that our replicas can also write to this. LiteFS has this halting mode that works by setting some file descriptor locks. And I think we just figured out the last issue, hopefully. Okay, so logs. Ooh, wait a second. EWR just did it correctly and it's not the primary? Oh, I think that was it. Nice, okay. So now we can do EWR can get fast. Boom. It's cached. London 1 Mississippi can also, this one's the primary, so this one was supposed to work. Awesome, and now if we wait 60 seconds just to confirm, we can go back to EWR where the cache will have expired. And it should still write to the database. Okay, so we've got a little bit there. Let's check out. Oh, actually, I could just do it. Oh, they're both cached. in EWR. That's fine. And then this is what's in the database. I need to change this so it doesn't dupe things, but that's up next. Oh, come on. What did I set this to? Is it still 1 minute, or is it more than that right now? Nope, slow server. No, 60 seconds. Okay. 1 Mississippi. Yeah, there we go. Haha! Yes! Our replicas can do writes now! Phew! We figured out what was going on, and it was just that I wasn't holding the file descriptor open long enough. When you close the file descriptor, you release the lock. So there we go. Everything's working great now. Wow, okay. This is going to be a perfect place to wrap up, and we'll have an awesome stream next time, just putting a bow on things and getting it all nicely wrapped up. Love that. Okay. Nice. What's going on over here? Haha, we figured it out. Actually, let's just do a big. We figured it out. We can use LiteFS halt correctly now. There were two big issues that we found today. First is that we were not using the OFD, open file descriptor, locks correctly. We were instead using the full file locks, which aren't what LiteFS uses for halt. The next issue is that we were closing our file descriptor before we actually wrote to the DB. When this file descriptor was closed, the OFD walk was released in the database, and the database was not writable anymore from the replica. The solution is to hold on to the file descriptor until we're done writing to the database. Oh, this is not tricky. This means we open the file descriptor before halting and use the same instance of the file descriptor to unhalt. Perfect. Yeah, awesome. Love it. Okay, but let's get my plan. Oops. Plan. Okay, let's move this 5th stream down to my history. Awesome. Sixth stream. Today we got LiteFS halt mode working. The last two puzzle pieces were to use the open file descriptor variants file locking, and to keep the file descriptor open for the duration of the halt process. Now we can do reads and writes from any node in our cluster. Ta-da. This means that when a replica gets a request for something it wants to cache, it can use the halt to acquire a write block and do its write. Then it releases the lock and allows other nodes to continue writing. It's not recommended to do this for, let's just say, for write heavy applications. But for our use case, it should be fine. Plus, I kind of want to stress test the halt functionality to learn where its limits are. Yeah, like I want to see, like how far in a write heavy app can we get before we need to do something different. So we did this, boom. Awesome. Okay, so now this is all kind of the tying a bow on it stuff that we're gonna do next stream. So we'll work on creating an endpoint to clear the file system cache. And we'll create an endpoint to clear the SQLite cache. Then we'll create an endpoint to fetch any missing pages from the origin. So this is if there's things, if there are things in SQLite that are not in the final system, we should fetch them from the origin. Perfect. And then move this cache population to a separate process that runs in the background. So instead of being an endpoint that we hit and it populates the cache, we want it to like check every minute or something, right? To see if there's things to cache. And then some of this just like making this app better and not for a specific use case. Move some of the hard-coded proxy information to a config file. So right now we like have the origin of our server in code, I think. Let's find out. We have some constants. Yeah, proxy from and proxy origin. So this is the URL that we will proxy from. So slow.coreyja.com is what's pointing to our CDN, and any request for this domain we want to forward to our origin, which is just running on the fly.dev URL that I got by default. So this config, though, we want to move to a config file so that it's not hard-coded. Along with that, we want to allow it to proxy multiple origins, so you can specify more than one domain to proxy from too. Writing an awesome README, I'm actually going to make that a quicker next step. I kind of want to get that done off stream, so that when we come to stream next time, we're just good to go. And then just some nice to haves. We want to make cache list return the TTL of the pages so that we can just see how long things have until they expire. Just a nice nifty thing to do. And we probably want to move the cache directory so that it's persisted. Right now we're doing it in a temp directory so that every time we deploy, the file system gets blown away. If we move this to something in our persisted volume, a deploy shouldn't necessarily wipe out that file system cache. So that'll be nice. A deploy then wouldn't have to reload everything that it had cached before. And yeah, and I guess there's two other things that we kind of want to add. Create, publish LiteFS RS to crates.io. Yeah, so I do want to publish the LiteFS RS. Man, that's a lot of letters in there. I want to publish that to crates.io so people can do the halt, unhalt, and check lag without having to implement it themselves. Just a nice nifty crate. I will use it in a few of my projects for when I want this type of thing. So I'll write this cleanup and publish. I think there's some cleanup to do as well, and maybe this specifically will be its own stream because we might also create something about file locking, a flock crate that can do this stuff for us. Because then I don't have to call libc directly in my LiteFS, and then I could make, maybe someone else needs this open file descriptor locking in Rust that it seems like no one else has really implemented, which makes sense. It's not hard just to call the libc stuff directly, so maybe that's why it doesn't exist already, but I think we should make it, so I think we will. Update the plan doc so we are ready for next time. And let's push that up. And there we go. Okay. I think that's gonna wrap us up for today, team. Let's go check out the repo there. Awesome. Okay, yep, we can see that the plan doc is updated, what we did last time, and our next steps, and we are good to go. I am really happy that we got everything working this time. Now both of our nodes, both of our primary and our replica, can write to the database. They just have to ask for a little lock first. It doesn't really seem to be making it much slower, though the server's already slow, so this extra locking bit's pretty quick. And I think probably some of the things we'll add eventually is like the LiteFS thing should probably record how long it took to do that lock, just for information. I think that would be really nifty to know, and stuff like that. So there's definitely some things to add. We've probably got 2 more streams, one to get cache, the application, all nice and ready to go, and then one to get LiteFS, the crate, all nice and ready to go. But then I think we will be wrapping up this project and moving on to something else. This has been a really fun one, though, and I think I'm probably going to end up using this in some more production-y workloads once we get it all wired up. So I'm excited for that. And I think with that, we are gonna wrap up and call it a day. Thanks for tuning in and hanging out with me. I always really enjoy these streams. So yeah, you can find me at CoreyJA.com. That's my blog and site. I do have a newsletter. It used to be weekly. I think I'm gonna change it to something maybe more like monthly, because I do love writing it, but every week was a lot, and I haven't published one in a few weeks now. So look out for an October newsletter for that coming up pretty soon, I think. You can check out that and all my other posts at CoreyJA.com. And with that, I think I am gonna get out of here. Have a great rest of your Sunday, team. It's nice and sunny where I am, so hopefully you can enjoy wherever you are as well. And have a great week, and I will see everyone later. Bye, team. Thanks for stopping by.